So I want to go through some just examples of doing L'Hopital's rule. Different scenarios you could see it in, different common mistakes that we see. So here I want to evaluate the limit as h approaches 0 of the square root of 1 plus h minus 1 over h. Some of you may recognize that this is the difference quotient for the square root of x when x is 1. But if you don't recognize it, that's okay. So even though this is the formal definition for the derivative of the square root of x when x is 1, not recognizing that's not going to really be a detriment here for this problem, in this scenario. So the first thing I would try is substitution. When I plug 0 into the top, oops, sorry, that's too hard to see. When I plug 0 into the numerator, I'd have the limit as h approaches 0 of 1 plus h all minus 1. Plugging 0 into that, I'd have the square root of 1 minus 1, which is 0. When I plug 0 into the denominator, I would also get 0. So this is the indeterminate form, h of 0 over 0. So I'm allowed to use L'Hopital's rule. So I'm going to indicate that I'm doing L'Hopital's rule. I have not found the limit yet. I am finding an equivalent limit. And for this, I need the derivative of the top and the derivative of the bottom. Well, the derivative of the bottom is much easier. That's derivative of h, which is 1. For the top, remember, radicals are not our friends in calculus, so I'm going to change that to an exponent. And now I can do the power rule on that for the derivative of the top. So I have 1/2, the inside doesn't change, subtract 1 for the new exponent, times the derivative of the inside, which is 1, and then minus the derivative of 1, which is 0. I'm going to do a little bit of simplifying here just to make things a little bit easier on myself. A negative exponent means it's going into a denominator. So this is going to be the limit as h approaches 0, because I still have not found the limit yet, of 1 over 2 times 1 plus h to the 1/2. So I showed it's the indeterminate form 0 over 0. I indicated I'm doing L'Hopital's rule. I found an equivalent limit. I didn't evaluate the limit yet. I just simplified it to make it easier to work with for me personally. That's not a required step. And I now start over and say, okay, let's try substitution. If I plug 0 in for h, I get 1/2. And here is our answer. I did want to also highlight some common mistakes, not so much with the idea of not showing an indeterminate form or not indicating L'Hopital's rule, but more of mathematical mistakes where people just make mistakes with the concept of L'Hopital's rule. So for both of these, I'm going to do one-sided limits. The fact is one-sided doesn't affect what I'm doing. So in this first one, I have the limit as x approaches 0 from the right of sine of x over x. I would try, or over x squared, I would try to do substitution first. So when I plug the 0 into the top, I get 0. When I plug the 0 into the bottom, I also get 0. So that's the indeterminate form 0 over 0. I am allowed to use L'Hopital's rule, which gives me an equivalent limit. Derivative of sine of x is cosine of x. Derivative of x squared is 2x. And now with this equivalent limit, I'm going to go ahead and start over and say, okay, let's try substitution. So if I plug 0 into the numerator, that gives me 1. If I plug 0 into the denominator, I get 0. Well, that doesn't work. I cannot do 1 divided by 0. So this is, now the mistake here is people say, okay, well, I'm going to do L'Hopital's rule again, but I can't. 1 over 0 is not an indeterminate form that we're allowed to use L'Hopital's rule on. I can only do L'Hopital's rule for 0 over 0 or plus or minus infinity over infinity. So with 1 over 0, common mistake, people would keep doing L'Hopital's rule, but I can't. Now remember, we're not equaling 1 over 0. We're approaching 1 over 0. So I have a number approaching 1 over a number approaching 0. So it'd be like 1 over 1/10, 1 over 1/100th, 1 over 1/1000th. So what's actually happening is this one, the number approaching 1 divided by a number approaching 0, that whole fraction is getting larger and larger and larger, and this is going off to positive infinity. The basic idea here is if I have a constant, if I approach, my limit approaches a constant over 0, I'm going to get either positive or negative infinity. But now if I switch this around and I look at the limit as x approaches 0 of x squared over sine of x, again, I would try substitution first. When I plug 0 into the numerator, it's approaching 0. When I plug 0 into the denominator, that's also approaching 0. So that's the indeterminate form, 0 over 0. I am allowed to use L'Hopital's rule, which gives me an equivalent limit. Derivative of the top would be 2x. Derivative of the bottom would be cosine of x. And I would try substitution again. When I try substitution again here, plugging 0 into the numerator gives me 0, so that's still looking good. When I plug 0 into the denominator, I get 1. A lot of people at this point would still go ahead and do L'Hopital's rule again, but that's not the indeterminate form, 0 over 0, or plus or minus infinity over infinity. This is actually something we can evaluate. We have 0 divided by 1, which gives us 0. And so what this means is if I have a limit that approaches 0 over a non-zero constant, and actually I should have said the same thing over here, a non-zero constant. Whoops. My apologies on that. I get 0. That's just to highlight two mistakes. Those are both scenarios where people are tempted to do more L'Hopital's rules, because L'Hopital's rules, once you're comfortable with derivatives, L'Hopital rule is fast. So I did want you to see an example of what about if I have infinity over infinity. So here I have the limit as x approaches positive infinity of the natural log of x over 2 square root of x. I would be trying to do substitution first. I can't really substitute in infinity, but as x gets bigger, the natural log of x also gets bigger, and that's going to be heading off to positive infinity. With the denominator, that as x gets bigger and bigger and bigger, 2 radical x also keeps getting bigger and bigger and bigger. So this is the indeterminate form, infinity over infinity, which means I'm allowed to use L'Hopital's rule, which gives me an equivalent limit. Derivative of the top would be 1 over x. 2 rad x is not friendly to us, so I'm going to change that to 2 times x to the 1/2. Its derivative would be 2 times 1/2, which is 1, times x to the negative 1/2. I'm going to choose to do some simplifying, so some scrap work off to the side here. 1 over x divided by x to the negative 1/2 is the same as 1 over x over 1 over x to the 1/2. Doing the division of fractions is multiplying by the reciprocal of the second. So I have x to the 1/2 over x to the first, which is 1 over x to the 1/2. So simplifying this gives me the limit as x approaches infinity of 1 over x to the 1/2. Well, as x goes to infinity, I have 1 over a number that's getting bigger and bigger and bigger and bigger and bigger. So this limit is approaching 0. And one final example, because I know this is a longer video with all of these examples. But I wanted you to see a chance not just with infinities, but also to see, hey, what happens if I have to use multiple L'Hopital's rules? And oops, I actually have a typo in here. This should be a 0. Sorry about that. So I have the limit as x approaches 0 of 1 minus cosine of x over x squared. Again, I would try substitution first. If I plug that into the top, that is approaching 0. When I plug 0 into the bottom, that is also approaching 0. So I have the indeterminate form 0 over 0, which means I'm allowed to use L'Hopital's rule. So indicate I'm doing that, which gives me an equivalent limit. Derivative of the top would be positive sine. Derivative of the bottom would be 2x. And I start over. I would see, okay, let me try substitution. So the limit as x approaches 0 of the top is approaching 0. The limit as x approaches 0 for the bottom is also approaching 0. That's an indeterminate form, 0 over 0. I'm allowed to use L'Hopital's rule, so I indicate that I'm doing that. To get yet another equivalent limit, derivative of the top would be cosine of x. Derivative of the bottom would be 2. And I would try substitution again. And when I try substitution this time, I get 1/2. And there is my limit.